All right, so today we're going to talk about triangles. And for this first part, we're going to talk about classifying triangles. All right, so there are a couple different ways that we can classify or sort or group triangles. First off, we can classify triangles by the lengths of their sides. And so I have three different classifications for side lengths of triangles. First type of triangle I have is an equilateral triangle. I have an isosceles, and I have a scalene. And so those are the three different types of triangle classifications based on side lengths. So for an equilateral, it kind of looks like it says equal, and then I know that lateral from the last video, lateral means side, so equal sides. And yes, that is absolutely correct. Also, we have what we call congruency marks. And so I know that we saw this back on our semester exam, and we hadn't talked about it yet, or I think we did anyway. I know we did in 5th grade. I'm not positive we saw it in pre-AP. But we have these congruency marks. And so congruency marks just mean that I have this side and this side are congruent, and then now I have another side that's not congruent. And so here I have three different sides, none of which are congruent. I don't know what the lengths are. I just know that where I see the same markings, then that means those are the same length. And so an equilateral triangle, equal sides, I have three equal sides, meaning all sides must be equal for an equilateral triangle. So I need to have all sides. Isosceles needs to have two or more. So there's a very important distinction here. Two or more. So is an equilateral triangle isosceles? Yes, it is. So because it has two or more, all of my equilateral triangles are also isosceles. So isosceles has two or more equal sides, and then a scalene has no equal sides or zero equal sides. And so if I have a triangle with three different side lengths, then that is a scalene triangle. You do need to know these classifications. All right, triangles can also be classified by the measures of their angles. All right, and so if I have three acute angles, or all of my angles are acute, then I would just call this an acute triangle. Or if I have a right angle, then this would be a right triangle, and it has one right angle. And if I have an obtuse angle, I would have an obtuse triangle, and it has one obtuse angle. And so here I have my obtuse angle, my right angle, and then my three acute angles. All right, so with that in mind, and another way that you can do this, and I'll have another video that I'm going to show you guys as well from Math Antics that I really like. But if I make an acute angle, and then I just connect it, that's an acute triangle. If I have a right angle, and then I connect it, it makes a right triangle. If I have an obtuse angle, and then I connect it, it makes an obtuse triangle. So it's the same type of thing, right? So three acute angles, one right angle, one obtuse angle, and so I can make those triangles. So acute triangle, a right triangle, or an obtuse angle. All right. Now, a couple of exploration questions. First off, can a triangle have more than one right angle? So that's an interesting thought. Can I make a right triangle with more than one right angle? So to explore that, the first thing I want to do is I want to draw a right angle. Now, from either one of these line segments, I want to add another right angle. Okay, can I make that into a triangle? Nope. So can a triangle, I'm going to try it again. So I'm going to do my right angle, and I'm going to try it from this one. Add another right angle, make that into a triangle. Nope, sure can't. So can a triangle have more than one right angle? No, it cannot. Why not? Well, because then it does not make a triangle. Can a triangle have more than one obtuse angle? I'm not sure. Let's see what happens. We draw an obtuse angle, and then from either one of those, make another obtuse angle, make that into a triangle. No, that can't happen. Let me try it again. This time from the other one, and nope, cannot. So can a triangle have more than one obtuse angle? No. Why not? Well, because then it doesn't make a triangle. So it's important to notice that to be an acute, to have that designation as an acute triangle, I need 3 acute angles. But to be a right triangle, I only need 1 right angle, or to be an obtuse triangle, I only need 1 obtuse angle, right? So those are important distinctions. So just because a right triangle has an acute angle, that doesn't mean anything. It has to have all angles have to be acute for it to be an acute triangle, but only 1 right or 1 obtuse to have the other titles. All right, so we just saw why right here. So let's review, let's look at a few different types of triangles, and let's see if we can classify these. And I want to give each of these 2 names. I want to classify them by the sides and by the angles. So first off, looking here, I have my congruency mark showing that I have 3 different side lengths. So I know that this is a scalene triangle, and looking at the angles, acute, 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 this must be an acute scalene triangle. Looking at the second one, I have 2 that are the same, 1 that's different. So I know that by the side lengths, I can call this an isosceles triangle. But then looking at my angles, acute, acute, ooh, look at that, there's an obtuse. So because I have 1 obtuse angle, this is an obtuse isosceles triangle. Looking at this one here, I have all 3 that are the same. So if all 3 are the same, I know that this is an equilateral triangle. And looking at all of my angles, yep, they're all acute. So this must be an acute equilateral triangle. This very next one, I see here, acute, acute, acute. So I know this is an acute triangle, but they don't tell me anything about the side lengths. And something that's going to be really, really important, and we'll see in a video later on today or later on in this lesson, that if all of my angles are the same, then my corresponding or my opposite sides are also the same. So I could say that all 3 of those are the same. And so I would have an acute equilateral triangle. All right, and we'll talk more about that. If that was a little bit confusing, that's okay. We'll talk more about that later on in the lesson. All right, let me fix my errors. All right, so here I have a 30 degree, a 60 degree, and a 90 degree. And I see that all 3 of my side lengths are different. So because all my side lengths are different, I know that I have a scalene triangle. And let's see, acute, acute. Look at that, that's a right angle. So this is a right triangle. It's a right scalene triangle. All right, looking at this one here, I have, yeah, look at that. I have an isosceles triangle. Look, it even confirms, right? So 2 equal angles and 2 equal sides. So isosceles. And I have, well, yep, there's an obtuse. So this is an obtuse isosceles triangle. All right, so now we've classified every single triangle by their side lengths and by their angle measures.